This is going to be Mechanics Year 2, Mixed Exercise 6, questions 4, 7 and 8 from the Mixed Exercise 6. I think I already said that. So we'll start with question 4, then we'll do 7, then we'll do 8. So if you only need one of the questions, just scroll forward a bit until you find where you need to be. So this one, projection is fired with a velocity 40 meters per second at an angle of 30. So let's get a diagram drawn for this. And that's an angle of 30 degrees. The projectile moves freely under gravity until it reaches the ground at point B. So the motion of the ball is going to go something like this, and then it'll hit the ground at B. Before we even start, we probably know we need to resolve the forces. So my upwards force will be 40 sine 30, and my horizontal force will be 40 cos 30. So we need to find the distance AB in part A, so let's go for that. Well, the best way to do this is most likely to, we can't just go straight ahead and resolve horizontally because we don't have enough information to do that. I'll set up a suvat to show that. So we want to find what S is. We know that the initial speed is 40 cos 30. We know that the acceleration is 0, and we don't have information about anything else. We most likely want to resolve vertically in order to find the value of time, because the value of time by the time it goes up and down will be the same as if it goes across for when it hits the ground, and we have a little bit more information about resolving horizontally because of the displacement. By the time it hits the ground again, the displacement will be 0 because it will have gone all the way up and then all the way back down. From its initial point, it will have moved 0. Up and down. Across, it will have moved some distance, obviously. 40 sine 30 for this. Acceleration is minus 9.8 minus gravity. And time, well, that's what we're aiming to find. We'll throw that value of time back into here then to solve. So S equals to ut plus half at squared. So 0 equals to 40 sine 30 t minus 4.9 t squared. If I go to solve that, I am going to get, well, in fact, 40 sine 30. Sine 30 is just a half. So this is, in fact, 20t. Makes it a little bit easier. So I'll probably just replace that all the way throughout 20. I can factorize this. So 4.9, I'll make it positive first. 4.9 t squared. Take away 20t equals to 0. Factorize out a t. So I've either got t equals to 0, which is at the start, obviously not what we're interested in, but we've also got it equals to 4.08, which is the one we are interested in. So now I've got my time. That'll be the same time for it takes to go across when it hits the ground. So now I've got enough information to solve this. So ut plus half at squared. Well, I know a is 0 in this, so actually all of this bit just disappears. So S, in fact, just equals to 4.08 times by 40 cos 30, which gets us about 141.39, and two significant figures will go 140 meters by the time we hit the ground again. Okay, part B was the one that probably caused us, I think, caused us a few more problems, just in terms of what they were actually wanting when they asked for the speed. So, best thing to do is let's resolve vertically to find the speed when it's 15 meters above ground. So SUVAT. Well, we know that this is going to be 15 because we're 15 meters above ground. Still the same speed. That'd be 40 sine 30, which is actually just 20. Acceleration is minus gravity. And then, oh, sorry, I should have put a question mark here because that's actually what we're interested in. And then time, not particularly interested in it, are we? So we've got v squared equals to u squared plus 2as. So v squared equals to 20 squared plus 2 times minus 9.8 times 15. Well, v squared equals 106. So v equals to 10.2956. That is just the horizontal motion. Okay, so it's going to be travelling upwards at a speed of that at that stage. In terms of resolving horizontally, obviously that's not a final answer, that's just one-dimensional motion. We've also got to consider the side-to-side motion. Because there's no acceleration and there's no forces acting on it in terms of left and right, u will equal to v. So in fact it will still be travelling at that same speed. If you were to set up a SUVAT and solve it, you'd get the same value. A lot of stuff would cancel out, equal 0, etc. So in fact that is what we are travelling at in terms of moving to the right. When it's asking for the speed, that is asking for, well, if we are going, let's just find what 40 cos. I'll keep it as 40 cos 30. So 40 cos 30 like that. And then in terms of travelling upwards at 10.2956. And the speed is the magnitude of that. So remember that is like our velocity because it's talking about direction. Speed just talks about the actual speed. We don't care about direction at all. And it's just the magnitude of this. So I can do some Pythagoras. All square rooted. So when I find that, I get 36.13. Again, two significant figures. 36 meters squared. So find out your speed in terms of vertical, find out your velocity, I should say, in terms of horizontal, and then do some Pythagoras. Okay, question 7. Let's get that in the center a little bit. So, again, so this time we're using gravity as 10, which is quite a bit annoying. I don't really like it, but it just means we have to round to one significant figure at the end. So, let's have a read. This is a bit more applied, this question. A boy is at a fairground. He throws a ball through a hole in a vertical target to win a prize. The motion of the ball is modelled of that as a particle that moves freely under gravity. The ball moves in a vertical plane, which is perpendicular to the plane of the target. The boy throws the ball horizontally at the same height as the hole. So let's just set this out. We're throwing our ball from here. The hole is kind of like there. It's at the same height. And we are throwing this horizontally. No angles involved. So this is kind of like towards the beginning of this chapter. And we're throwing that at a speed of 10. So there's no 10 cos this and 10 sine that because there's no angles involved in this setup. And when he does hit it, he doesn't get the hole. He's pretty rubbish at this game. He hits it 20 centimetres below. We always talk about meters, so I'm going to change that to 0.2 meters. So that's where he actually hits. That's the whole of what he was aiming for. That's the setup of our question. So we want to find the horizontal distance from the boy to the hole. So we want to find this. We'll call that x. So part A. First thing I'm going to do is, well, I want to find the horizontal distance. So let's just set up a SUVAT equation resolving horizontally, because ideally we will want something like that. We'll see if we've got any information at this moment. Maybe we do, maybe we don't. Well, that's x. This is 10. We don't know the final speed. The acceleration is 0, and time, we don't have anything for it. It seems like we need one more value in here. So we'll probably resolve vertically to try and find that value of time that we are after. So we know in terms of this, he's gone 0.2 down because it's gone from the level surface to 20 centimeters below, so minus 0.2. The speed is 0 because he's not throwing it in any way up or down, it's just directly across. The acceleration is minus gravity, and t, well, we'll go ahead and find that. So let's use s equals to ut plus half at squared, so minus 0.2 equals to, well, that turns to 0, and this turns to minus 4.9 t squared. So 0.2 equals 4.9 t squared. Let's divide by 4.9. Let's square root. We are going to get, oh sorry, I've realised this should be minus 10, shouldn't it, because of using 10 in the question. So this should be minus 5. This should be 5. So let's divide by 5 and then square root. I'll get t equals to 0.2, like that's on the dot, no rounding. So that goes in there. Don't know why I wrote that again. Now we can work with this to find out this horizontal distance. So s equals to ut plus half at squared. Again, all of that disappears because a is 0. So x equals to 10 times 0.2. Well, x equals to 2. So in fact, he is 2 meters away from his target. So that's the answer to the part A. Okay, part B. Can use this same diagram, I think. So the boy throws the ball again with the same speed and the same distance, so he's still 2 meters away, still throwing it at 10. This time he throws it at an angle, so he realizes that doesn't work. He's going to throw it at an angle to get it into the hole. Work out the possible angles. So it seems like there's 2 ways he could do it. Maybe he could throw it a bit higher, like alley-oop it in, and then one he can go for a bit more of a direct motion. But it's our job to find out what them angles are. So he's still 2 meters away. We don't know what these angles are. Any more information we want to add on? Oh yes. He's throwing it at a speed of 10. So we've got some things like, we've got the 2 speeds, we've got 10 cos of our angle and 10 sine of our angle. Okay, let's just go from there. Seems like a bit of a rinse and repeat with these style questions. We're resolving in both ways and then trying to find something smart we can do in order to collect all the terms. So first thing I'm going to do, I'm going to resolve vertically. I know to get it into the hole, s must equal 0 because we're at the level surface. We want it to kind of be at the same height as it was at the start. We know the initial speed is 10 sine theta. We don't know the end speed. We know the acceleration is minus 10, still using 10 in this question. And time, we don't know. So we've got 2 unknowns in here. We've got an angle unknown and a time unknown. So we can start off forming this equation, but we most likely need to resolve horizontally to solve it properly. So let's just start off with this. So 0 equals to 10t sine theta minus half a, which is 5 minus 5 t squared. We'll tidy it up a little bit. We've got, I'll make this positive, so 5t squared minus 10t sine theta equals 0, then I'll factorise out t. Might be useful, might not, but it just tidies it up a little bit. Can't do any more than that. So let's just leave it there. Well, in fact, we could say that t equals to 0, which is at the start, which we don't care about, or t equals to 2 sine theta. We definitely can't do any more after that, because we need to find the angle. So let's resolve horizontally. We know that he's travelling 2 meters across. We know his speed is 10 cos alpha. We don't know the end speed. We know his acceleration is 0. And we know time, well, is the same value of time here. So why don't we use this value? Instead of using t, we'll use 2 sine of our angle, because it gets rid of an unknown t. We've only got one unknown now, so it's looking a bit more promising. So let's go for s equals to ut plus half at squared. So 2 equals to, well, that will be 10 times by 2 is 20 sine theta cos theta, and all of this goes. Where can we go from here? This is an identity, so this is a bit one of these horrible ones where it uses an identity that we don't really know yet. But 2 sine alpha cos alpha equals to sine 2 alpha. So without knowing that, there's not really much you could do from this point. So let's replace that. So I know that this is kind of like 10 times by 2 sine alpha cos alpha. So this is 10 sine 2 alpha. Still all equals to 2. Let's divide by 10. So 1/5 equals to sine 2 alpha. I'm just going to move down a little bit. So I need to inverse sine that. That will tell me what 2 alpha equals. 2 alpha equals to, that says 11.5 from the calculator. I'll just triple, nope, I won't double check that. I'll believe my working out. I'll just check that, but it says possible values. So we need to just do a little bit more. So, sorry, just from that, we can say that that's 5.75 there. However, we just need to do a little bit more. So have a look at the graph. Have a look at what the value would make sense. Got my sine graph here. Well, if I've got 11.5 there, it would make sense to also have this solution here of 180 take away 11.5, because it would still be possible to throw at that angle. Yeah, it would still be possible to throw at that angle. So that would be 168.46. 11.5 is a little bit rounded. This would be the exact. It's probably taken away 11.54 or something like that. But obviously 2 theta equals to that. You might be thinking, well, that's throwing it behind him. That doesn't make any sense. But that's what 2 theta is. So in fact, theta would equal half of that. So that would equal to 84 degrees when I round it as well, to 2 decimal places. I should probably round it to 1 decimal place with the style of the gravity in the question, but I just feel like that would be so inaccurate or inaccurate that I'm not going to bother with it. So 84 degrees and 5.8 degrees to 2 decimal places. So we could kind of throw it really high up in the air and it would loop in, or you could throw it pretty low and it would also go in. There's a pretty tricky end to the question. It's not so obvious that you need to do that, but always do look out and draw the graph, especially if they're asking for possible angles or possible solutions. Okay, and the final one. These always take longer than I expect. Long questions, aren't they? Whoa. Okay. Here we are. I'll not mess about with it anymore. So final question, question 8. Again, we're using gravity as 10. They've been so nice to draw a diagram out for us. Let's just add our forces on, going down and right this time. So this is going to be 20 sine alpha, 20 cos alpha. I've just spotted in the question here that tan alpha equals 3/4. That means that if we had a right angle triangle with alpha there, opposite over adjacent, that must be a 5. So sine alpha equals to opposite over hypotenuse, and cos alpha equals to adjacent over hypotenuse. So I am in fact going to replace this. So 20 times by 3/5. That is 12. And then this is 20 times by 4/5. So it is 16. So I'm going to be using them values instead, 12 and 16, instead of the cos alphas and sine alphas. Okie dokes. I think all the information from the diagram is from the question is all labelled on the diagram, no problem. So I'm not going to read it through. Let's just go straight in for part A. So part A, the time taken for the ball to travel from P to Q. So from here to the ground. Well, let's go for a suvat. If I resolve, I'm going to resolve downwards this time. So down is positive for me. The reason I'm doing that is because the ball is being shot downwards. And I feel like if I resolve upwards, I'll have a load of negative values. So in this case, the displacement is 10, not minus 10, because I'm resolving downwards. I'll make that a bit clearer. I'm resolving downwards, so 10 meters down is positive 10 to me now. My speed is positive 12, the 20 sine alpha. Don't care about that. Gravity is 10, positive 10, because I am resolving with positive being downwards. Gravity points downwards. And then time is what we're actually after, so we'll stick that there. So S equals to UT plus half AT squared. 10 equals to 12T plus 5T squared. 5T squared plus 12T minus 10 equals to 0. Most likely you can't factorize it in these questions, so just quadratic formula it. So x equals to, I think I got minus 3.106 and 0.657. Obviously, why did I put x? I mean t. But obviously that's not a sensible answer. This is the sensible answer. So that is our time it takes to hit the ground. Not really worth the 5 marks there, but maybe because it's including all this tan sine cos alpha business. The distance TQ, well that's just that extra little bit, so I'm probably going to find the distance OQ. So let's go for OQ, and then we'll just take 9 away from it. I'm going to resolve horizontally. Well, the displacement is what I'm actually interested in. I know my initial speed is 16. I know my acceleration is 0. And I know time, well, to get to Q, it's going to be the same as the time for it to go from P to Q in terms of vertically. So 0.657. Just realised I probably should have rounded that, shouldn't I? 0.662. Significant figures. Maybe 0.7 to one significant figure because we're using 10 as gravity. So S equals to UT plus half AT squared, so X equals to 16 times by that. Well, that all goes to 0 because A is 0. So not that annoying of a substitution to do. That gets me 10.512, but obviously that is this whole distance. 10.512. I need to now do for TQ, that is going to be that, take away 9. So 1.512. So let's just call it 1.5 meters to 2 significant figures. And then C, the point A is on the path vertically above T, so we know A is going to be there, and the key thing about why they've told us that is that it is 9 meters horizontally. So, first thing, we want to find the speed of the ball. So again, we want to find the velocity in terms of moving to the right and the velocity in terms of how we're moving down, and then do some Pythagoras to solve it. So we need to solve that in both ways. Let's go for a Suvat. Let's resolve downwards first. No real reason why. It's just what I've got in my notes. So let's resolve downwards first. We don't know the distance that we are going down at that point. We could find it, probably not worth the effort. We know the initial speed is 12. We know the acceleration is 10. We are after the speed this time, and we don't know the time just yet. So before we can do anything with this, we probably need to resolve horizontally to find that value of time to use in that top equation. Otherwise we can't find that speed. We already know in this, because there's no acceleration acting on it. So again, u equals to v, which equals to 16. So we already know that's 16. I'm not using this equation to find out the value of v. I know it already. I'm using this equation to find the value of t. Acceleration is 0. We know we've travelled 9 across at that point because a is directly above t. We know the speed is 16, and we don't care about that. So s equals to ut plus half at squared. Feels like we use this constantly. It's pretty boring. That goes. So what? T equals to 9 over 16. Cool. Let's throw that back into here. And then we can actually finish off this working out. Oops, wrong one. V squared equals u squared plus 2as. I just got so used to writing s equals ut plus half at squared, I might buy a stamp that says it so I don't have to write it anymore. Chuck all that in your calculator, square root it, you're going to get v equals to 17.625. So that is my speed in how I'm moving downwards. This is my speed in how I'm moving across. So let's set up a little triangle business of that. Well, the speed, I'm not really drawing it right, we're not moving in that direction, but it really doesn't matter. It's the idea of the speed. I should have probably drawn the 10 across here and then drawn that arrow like so. Same answer. Pythagoras, so I'll just finish it off down here in red. 16 squared plus 17.625 squared, all square rooted. That is going to get you 23.8 meters per second. We could possibly call it 24 to 2 significant figures. 20 to 1 significant figure because we use g as 10, but again, I hate that level of accuracy being pretty rubbish, so I'm not going to bother. So there we go, that's our final answer to C. Okay, hopefully that was helpful.